Evening, folks. Brian here, Geomagnetic Earthwatch, Friday, May 2nd, 2025. We're going to continue the topic of Earth's weakening protective magnetic field, and I'm going to introduce something which is going to be a complication in just a very few short years. So as stated, my idea, my theory, my suggestion, what happened with the grid down in Spain, France, Portugal area. So there was no solar impact event. There was no solar flaring, no CME, no filament eruption, no radio blackouts, nothing. But a minor increase in the plasma density simply from the solar winds coming in. And I believe it found a crack, an opening, weak field lines. Now, because of the ongoing geomagnetic excursion, at some point, if not already, it's going to develop a multiple polar field. It's very late. I want to go to bed. Of chaotic instability with multiple magnetic poles developing here and there sporadically around our planet, popping up and then disappearing, changing. And this creates a further destabilization of the magnetic field lines, opening up vastly, creating openings in the protective magnetic field. Perhaps even completely non-existent for periods of time, spotty areas over the planet. And the first one being over Portugal, Spain, France. If you've been around long enough, you know my daughter's globe and what I've done to it. So the white flags is where the magnetic pole used to be. Nunavut, Canada, until approximately 1903, 1905. More or less in the middle of the Antarctica. This is based on 2019. The red pin flag is that where it was then, heading into Siberia. The red one here, between Antarctica and Australia. You get the point. So they're on an excursion and they're drawing towards each other. Okay, they're drawing towards each other. The focal point, the meeting point, is somewhere in the Indian Ocean, Bay of Bengal. It doesn't matter exactly where it's going to be because we're not going to be here by then. We'll be dead, so don't worry about it. So the pole, right now, so the poles are drawing closer to each other. I've said this so many times over the past couple of years. This means on the other side of the planet, the distance is increasing between the poles. Opening up, increasing, wider field lines, weaker protection over that area, which just happens to be the Americas. But now we are going to be developing multiple magnetic poles. Now, there's two types of cosmic radiation, folks. There's the one we often hear about, and that is the solar from the sun rays, the highly energetic particles. However, there's galactic cosmic rays, which are more energetic. They come from the remnants of solar explosions, supernova, etc., and from cell. So when a cosmic rays reaches the atmosphere, it interacts with the atmospheric atoms, where a cascading showering effect, changes take place. A single cosmic rays changes to several secondary showering particles we call muons. which reach the Earth, pass through us, pass through the crust, and when it interacts with the silica-rich magmatic bodies, boom booms happen. It is also the cosmic rays which depletes the protective ozone layer, which in turn allows increased levels of ultraviolet radiation, including now the sea level. It is the ultraviolet radiation which causes cancers, skin cancers, eye cancers, suppresses the immune system antigen presentation response. And a whole bunch of other problems and issues. Causes droughts. It sucks the moisture out of everything. Changes the DNA not just in humans, but in plants. I found this out many years ago. This is why I cover as many as my vegetable gardens with polycarbonate panels. Now we're going to introduce a problem we're going to have in just a very few short years. My research and study started with grand solar minimums. Grand solar minimum is a period where the sun goes into a state of hibernation, minimal to no sunspot activity. So the last, and grand solar minimums happen on average every 400 years approximately. The last one was the Maunder minimum, which was from 1645 to 1715, also called the mini ice age. So during that period of time, during that 70-year period, there were only 50 sunspots. Normally, there would have been 50,000 sunspots. Then we had the grand minima, the Dalton minimum, which was from 1790 to 1830. It is important to realize that during grand solar minimums, there's an increase in earthquakes and volcanic eruptions. Back to the Maunder minimum, January 26, 1700 was the Cascadia subduction zone megathrust earthquake. During the Dalton minimum, April 1815 was the Tambora volcanic eruption, followed by the year without summer, 1816. There was also the two New Madrid earthquakes in 1810, 1811. So let me explain. The sun has its own protective magnetic field called the heliosphere, which expands out greatly and envelops and protects the planets from the harmful galactic cosmic rays. But during grand solar minimums, the heliosphere shrinks, leaving the planets more exposed to the galactic, the more highly energetic galactic cosmic rays. And this is why during grand solar minimums, we have an increase in earthquakes and volcanic eruptions. Now I need to explain the standard 11-year solar cycle. So the sun will increase in density and decrease. It's called 11-year solar cycle. It'll start off with minimum solar activity, sunspot activity, and it will gradually ascend to solar maximum about 4.5 years later. This is where we're at right now. We're solar maximum, solar cycle 25. Then it'll start descending back down to solar minimum and so on. Now, a few years before, it was assumed that at the end of this current solar cycle, we will be entering into a grand solar minimum, which is normally when you have 3 consecutive solar cycles, each one decreasing in sunspot intensity activity, and so on. 3, that is the main indication we're going into grand solar minimum. However, our sun, Sol, has not been acting the way it should. It's been hyperactive, especially at the backside where Sal is coming in. It should be noted that not all solar cycles are 11 years. Some have been 14 years. A couple have been only 9 years. So if this current solar cycle 25 behaves as it should, which it hasn't been, then we'll be back at solar minimum 2030, or let's say 2028 going into 2030, we're going to be descending. Unless that's a shorter solar cycle, which means around 2027, let's say. It gets confusing. There's a lot of information you have to wrap around. My point being that if the sun's protective heliosphere, let's say in another 2 to 3 years, starts to shrink on itself again, leaving us more vulnerable to galactic cosmic rays and radiation from cell, add on to the fact, people, we are undergoing a geomagnetic excursion. Our own protective magnetic field is already breaking down severely, harshly. We're even more exposed now to all the different forms of radiation coming in. So in another 2 to 3 years, remember the modeling I showed you of our planets in orbit around the sun. And then the intersection of the secondary system coming in, the binary system. So in January, February 2026, and again in 2 more years in 2028, there's going to be a time when all the planets are going to be on one side of the sun, except for little old Earth on the other side. So we're not going to have the inner planets, the other inner planets, helping us out by absorbing some of that energy from Sal. And who knows the state of our own magnetic field by that time. If I am correct, and one of those zones all of a sudden developed over Portugal, Spain, France, who knows how long it's going to be there? Is it going to grow? Is it going to close up, head off somewhere else? So I just wanted to introduce this complication of the grand solar minimum and how it's going to be affecting us. Actually, it might not even be here. I think that's going to be it for this talk. The main point is the amount of the highly energetic particles, the radiation levels reaching us. That's going to affect our immune system, our DNA, our mind. More energetic particles penetrating the crust, resulting in pressure, earthquakes, volcanic eruptions, fires. And that is all, as you were.